All right, let's get started. I'm Ghost. He's Spectre. Now, if you're in this room, it's probably because you've hit a wall. You're good, no doubt. You find bugs, you cash the check, you move on to the next target. But you've got that feeling, right? That little voice in your head telling you there's a whole other game being played, one you can't even see yet. Well, that voice is right. And today we're not just handing you a new set of tools, no. We're here to do a full stack upgrade on your entire way of thinking. So forget about bug bounties. That's just picking locks on a door. We're here to teach you how to get the master key to the entire damn building. We're talking about systemic, total compromise.
So let's get one thing straight, right here, right now. What you're about to learn isn't about finding some clever little cross-site scripting bug or another run-of-the-mill IDOR. This is about a fundamental shift in how you see the world. It's the difference between finding a single crack in one wall and owning the architectural blueprints to the whole fortress. One of those gets you a small payout and a pat on the back. The other gets you the keys to the kingdom.
He's not kidding. Those bug bounty programs you work in, they're a comfortable lie. They hand you a neat little scope, a list of rules, stuff you're not allowed to touch. It's a padded room designed to keep you safe. Out here, in the real world, there are no rules. There are just objectives, there are assets you need to acquire, and there's a ceiling on what's considered an acceptable loss to get the job done. If you can't wrap your head around that, you're going to be a bug hunter forever. We're here to train operators, and that's a whole different goddamn species.
Okay, let's get into it. Here's the roadmap for rewiring your brain. We're going to start with digital blueprinting. That's where we teach you how to read a target's soul from its own code, long before you send a single packet. Then we move to forging the keys, where we take that intel and we weaponize it in our lab, not their production environment. After that, well, things get a little darker. Becoming invisible is all about building our ghosts so we can whisper in their network. Conquering the kingdom is how we take it all without them ever knowing we were there. And then, maybe the most important part, erasing the footprints, because a true operator is never, ever found. So pay attention. This is the entire playbook.
First things first, digital blueprinting. You know, to an amateur, static analysis means running some scanner or maybe grepping for the word password in source code. But to an operator, it's the single most critical intelligence gathering phase of the entire operation. The mobile app is not the target. Let me say that again so it sinks in. The mobile app is not the target. It is a meticulously detailed, constantly updating intelligence dossier on the real target, the back-end infrastructure. It's the map, and it's going to lead us right to the treasure.
And this shit right here is exactly why we start here. We had this one job, massive fintech company. I mean, everybody was just hammering their web front ends, their trading APIs, and getting absolutely nowhere. So we were tasked to find a different way in. We pulled their employee-only corporate wellness app. It was this stupid, simple little health tracker. The company's own blue team just ignored it. To them, it was a joke. So we decompiled the Android APK, and buried deep in the resources was this little comment left by some overworked developer. It said something like, "To do, remove debug endpoint for backend config." And boom, there it was. A URL, an internal, completely unauthenticated API endpoint that let us not just view, but, as it turned out, modify the feature flags in the configuration for their entire production environment. We could literally just turn off their security features. Game over. And all because we took the time to read the damn blueprints instead of just trying to kick in the front door.
So this is a crucial distinction to understand from an operator's point of view. Static analysis, what we're calling our blueprinting phase, is all about deconstructing the artifact they ship to build an intelligence profile. We don't run the app. We dissect it. We treat it like a captured piece of enemy equipment. We learn its intended design, all of its components, its entire supply chain. Dynamic analysis, which we'll get to in a bit, that's more like active surveillance. It's watching the target in its natural habitat to see if it actually behaves the way the blueprints say it should. See, trying to do that active surveillance without the blueprint, that's like trying to tail a spy in a foreign city without a map. You're just asking to get caught. Blueprint first. Always.
Okay, so here's the core process for this phase. Think of it like a three-step waltz. First, we deconstruct the app's identity. What does it claim to be? What capabilities does it declare to the operating system? This is basically its official passport, and we're going to study every page. Second, we perform an autopsy on the binary. We gut the thing. We rip out every single domain, URL, and API endpoint we can find. We're not asking for its list of contacts, we're taking them. And third, we map its entry points. How can it be woken up? Deep links, background services, push notifications. These are all the doors into the house. We're not trying to pick the locks yet, we're just cataloging every single door and window. Now in Android, your first stop is always the Android manifest.xml. This is the absolute canonical source of truth. And I want you to think of it this way. This isn't just some config file. It's a sworn statement that the app makes to the operating system. So when it declares an exported component, it's literally telling the OS, hey, any other app on this phone can talk to this piece of my code. That's a doorway. When it defines an intent filter for a deep link, it's basically hanging a sign out front that says, open for business at this address. And when it sets a network security config that allows for user-installed certificates, well, it's telling you that its own developers wanted to man in the middle themselves. It is the very first document we interrogate in any operation, because it tells us where the bodies are buried before we even have to pick up a shovel.
So, what's the actual output of all this work? It's a document, your app_profile.md. This becomes your target dossier. For an Android target, we're cataloging every single exported component because that's our inter-process communication, or IPC, attack surface. We're making a special note of the network security config because that tells us exactly how paranoid or not they are about their TLS. For iOS, we're grabbing the associated domains because those universal links are privileged entry points into the app. And the NSApp transport security exceptions? That's a beautiful, neatly organized list of all the domains where they've deliberately weakened their own security. Every single line item here is a potential thread we can pull on later.
All right, my turn. Ripping the intel straight from the code. This is where the real fun starts. This isn't theoretical anymore. This is surgical. I mean, look at these signals. You find serialization libraries like Mashi or JSON. That's not just code, man. That is the server's entire data contract, spelled out for you in plain text. It includes every single field they know how to process, even the ones the UI never shows you, like add as admin or plan tier. Feature flags, that's a treasure map to the server's hidden logic. You find a flag called enable admin refund flow, and you know for a fact that a powerful hidden API exists somewhere. The auth flow logic, it tells you exactly how the server decides to trust a device. We're not looking for client-side bugs here. We are looting the client for server-side intelligence. And this right here is the tangible output of all that intelligent looting Spectre was talking about, your mobile API seed/directory. Now let's get into the weeds here for a quick technical deep dive. This is not manual labor. You script this. You're using tools like JADX to get readable Java code, sure, but then you're writing your own custom grep patterns and Python scripts that just walk the decompiled source. You're looking for class constants that define API paths, or for retrofit interface annotations like @get or @post. You're specifically hunting for the definition of the data models, the POJOs or the Kotlin data classes, because they are a one-to-one map of the JSON the server is expecting. And here's a pro tip. Look for the OKHTTP interceptors. That's where developers love to inject static headers, API keys, and user agent strings. Automating this extraction process is what separates the pros from the people who waste weeks doing it all by hand.
Okay, so let's bring this all home for phase one. This slide, this is the core lesson. The bug bounty hunter, they find a hard-coded key in the client, they report it, they get paid. For them, the client-side issue is the end of the road. But for an operator, that same key is just the beginning. The client is a disposable tool. It is a means to an end. Our goal during this phase is to deconstruct that tool to build a complete, exhaustive intelligence profile of the server-side infrastructure and its rules of engagement. We couldn't care less about insecure storage on the phone. We care that the data stored on the phone reveals the entire structure of the database in the cloud. It's a total, fundamental mindset shift.
Okay, phase 2, forging the keys. So if static analysis was us reading the enemy's training manuals, then dynamic analysis is us putting a spy on the inside to watch their actual troop movements. We've got the blueprints, now we're going to observe reality under completely controlled conditions to see how the server really behaves. This is where we validate all of our assumptions and we observe the server's soul in motion. We're not guessing anymore, we're watching.
And hey, before we go any further, let me tell you a little war story. This shit is why we have labs. I once saw this guy on a contract, smart kid, but cocky as hell. He gets this theory about a session integrity bug on a major banking app, but instead of modeling it out in a safe lab environment, he got impatient. He wrote a script to test it directly against their production login API. He created some race condition he didn't anticipate and ended up invalidating the sessions of about a third of their active user base. Took down their entire prod environment for 3 hours. The kid got fired, his company got sued, and he's damn lucky he didn't face criminal charges. Don't be that asshat. Your lab is a sanctuary.
All hypothesis testing, all error generation, all your weird experiments happen in your environment. Never, ever on a live target.
And Spectre's point is really the foundation for this entire phase. Our process here is one of clean, sterile observation, not disruption. So, step 1 is establishing a clean capture posture. And that means a dedicated device or emulator, a trusted interception proxy like burp or mitten proxy, and meticulous, organized logging. Step 2, we model the session lifecycle. We capture the full dance: login, token refresh, logout, device registration. We need to understand the server state machine perfectly. Step 3, we observe the gates. We'll use an older version of the app. We'll toggle some of those feature flags we found back in phase 1. Does the server actually enforce the gate, or is it just the UI that's hiding the button? And finally, we record the mobile-only flows, the stuff that simply does not exist on their web platform. That's where the real gems are usually hidden.
And this brings us to a really key concept: the mobile delta. I mean, think about it. A company's web API has been hammered by security researchers for years. It's battle-hardened. But the mobile API, it often has features the web doesn't. Think about things like file uploads directly from a camera, device bootstrap flows, those admin-adjacent actions for internal support apps that were built on the same platform. This delta, this, say, 20% of the API surface that is mobile-only, is often newer, it's less tested, and it was probably built with a totally different set of assumptions. It is an operator's prime hunting ground for high-impact server-side vulnerabilities. This chart visualizes that concept perfectly. You see, everyone is fighting over that 45% web API surface, and the 35% that's shared between web and mobile. But as an operator, your focus is that 20% mobile delta. Why? Because it was probably built by a different team on a different timeline with completely different security assumptions. The web team's been getting slammed by auditors and bug bounty hunters for a decade. The mobile team? They were probably just under pressure to ship a feature fast, and they thought, no one will ever call this endpoint directly. They were wrong. And that little slice of the pie, that's the continent we're here to conquer. And here's your hit list for that delta. These are the flows you need to capture cleanly every single time. Device registration is number 1. How does the server learn to trust a new piece of hardware? The entire security of the system can hinge on that very first handshake. Payment tokenization, even if it's just in test mode, reveals the logic the server uses to handle money. And my personal favorite, admin-adjacent actions. We once found an internal, employee-only version of a customer support app, and it had an API endpoint to reset a user's MFA. The only thing protecting it was a simple client-side flag. The server didn't even check the user's role. That is a kingdom-level key just sitting there in a mobile-only flow. Okay, this is crucial. As you're capturing traffic, you'll often see the client sending redundant information. The bearer token, for instance, contains the user's identity and maybe their organization ID, all cryptographically signed. But the request might also include a header like xorg ID, or maybe a JSON body field like org ID. This right here is the single most important question you need to answer during dynamic analysis. Where does the server derive its sense of tenancy? Does it trust the verifiable signed claim in the token, or does it trust the easily manipulated user-controlled header? Because if it's the latter, the entire authorization model for the application is fundamentally broken, and you likely have a critical system-wide cross-tenant access vulnerability on your hands.
And this is how we turn that question into a scientific experiment. We practice what we call hypothesis-driven testing. We don't just spray and pray with a bunch of random fuzzing lists. No. We form a clear hypothesis based on the intel we've gathered. For example, our hypothesis is the server incorrectly trusts the org ID header over the token. Our observation is that the client sends both. So our lab-safe test is to take a valid captured request for org A and replay it in our lab with the org ID header changed to org B. The server must reject this request. If it processes it and returns data for org B, you have just scientifically proven a critical systematic flaw without ever endangering the production system. We do this for every single high-value hypothesis we generate.
So, to wrap up phase 2, let's look at that elite contrast again. The typical pen tester, they fire up Burp Suite, they send a request to Repeater, and they start throwing payloads at it, hoping to trigger an error or find a simple IDOR. They're looking for bugs in a single request. An author-rater's goal is entirely different. We build a clean, replayable, perfectly modeled representation of the server's entire state machine. And then we use this model to scientifically and safely test our hypotheses about systemic authorization and logic flaws. We are not hunting for bugs. We are auditing the integrity of the entire system. And as Spectre made painfully clear, we never induce errors on a live production target. That is the creed.
All right, now we move from the lab and into the field. Up until now, we've been ghosts on the outside, just looking in. Phase 3 is all about becoming a ghost inside their machine. And this isn't just about getting a shell. It's about establishing a persistent, completely undetectable presence. It's about building your command and control infrastructure so that it just becomes part of their network's normal background noise.
And this right here is the core principle, the prime directive of C2 design. Your command and control traffic must be utterly, completely, and forensically indistinguishable from the target's own legitimate application traffic. And for a little technical deep dive, this means you're not just matching their user agent string. Oh no, you are analyzing their TLS handshakes, and you're replicating their exact JA3 hash. You're using domain fronting through the same CDNs they use for their legitimate traffic. You are matching their beaconing intervals. If their mobile app checks in every 7 minutes with a small JSON payload, then your C2 implant checks in every 7 minutes with a similarly sized, similarly structured payload. You don't give the defenders a single, solitary thread to pull on. Let me put this bluntly. If your go-to move for C2 is firing up Cobalt Strike with its default profile, you might as well just send the blue team a calendar invite for your exfiltration. I remember this one crew. They thought they were hot shit. They got into a Fortune 500 company and immediately spun up a CS beacon with a default malleable C2 profile. The blue team's EDR flagged it in under 5 minutes. 5 minutes. The whole op was burned because they were lazy. A professional operator builds bespoke C2. That means if their backend talks GraphQL, you're not sending base 64 encoded shell commands over HTTP post. No, you're wrapping your commands inside what looks like a legitimate GraphQL mutation. You're exfiltrating data inside what looks like a valid query response. You are using their own application protocol as your covert channel. That's the difference between a loud-ass script kiddie and an actual operator. Okay, let's move to phase 4, conquering the kingdom. So, you've achieved initial access. You've got a foothold. Now what? Well, the amateur drops a bunch of tools and starts making a ton of noise. The operator begins to move silently through the network. This is where the real damage is done. Your initial foothold is fragile. It can be taken away. The real goal is to become so deeply embedded in their infrastructure that they can't get you out without burning the whole thing to the ground. That is total persistent control.
The principle here is a concept you may have heard of, living off the land, or LOTL. The best, most effective, and by far the stealthiest tools are the ones the target has already installed and already trusts. So for our technical deep dive, instead of uploading a port scanner, use the built-in netshesh command on Windows, or you query their own internal service discovery APIs. Instead of using a custom credential dumper like Mimikatz, which every EDR in the world is looking for, you use PowerShell to interact with the LSSS process in memory, or you leverage built-in Active Directory tools to perform curb roasting. See, the defenders are expecting to find your malware. They are not expecting their own administrative tools to be turned against them.
And this is the real difference maker. The script kiddie gets a shell and immediately tries to upload Mimikatz to dump credentials. That's like setting off a flare in the dark. The blue team will be all over that host in minutes. The professional? We go back to our phase 1 intelligence. Remember that unauthenticated backend config API we found in that stupid health app? That wasn't just our way in. It's also our map for lateral movement. We saw their internal CI/CD service, their Slackbot integration, their user management endpoints, so we don't drop tools. We use their Slackbot to run commands on other servers. We use their deployment pipeline to push a backdoored update. We're not a virus they can detect with a signature. We're just another user of their own trusted systems. It's almost impossible to defend against. And that brings us to the final and honestly the most often fumbled phase of any operation, erasing the footprints. You've gotten in, you've conquered the kingdom, you've achieved your objective. Amateurs celebrate here. Professionals know this is the moment of greatest danger. Getting the data out and tearing down your infrastructure without leaving a single trace is the hardest part of the entire job. You botch this and everything you did before was for nothing.
Exfiltration is not something you figure out at the end of the mission. It is planned during phase 1. So for the deep dive here, you're identifying potential covert channels from the very start. Can you use DNS tunneling to exfil data in AAA query requests? Can you hide data in ICMP packets? Or more commonly, can you find a benign, high-volume HTTP endpoint like an analytics beacon or a file upload and just blend your data into that stream? I saw a team once try to exfiltrate 10 terabytes over a raw TCP socket at 3 a.m. They lit up every single DLP and network monitoring tool in the building. It was just a race between them downloading and the sysadmins pulling the plug. A complete and total shit show. Don't be that guy.
A professional exfiltrates data like a slow poison. We use that file upload pipeline from phase 1.
We chop our data up into tiny, encrypted chunks. We might use steganography to embed our encrypted payloads right into the image data itself, so that even if a defender inspects the file, it just appears to be a valid, non-malicious image. Then we talk cleanup. You're not just running RM on your tools, you are securely wiping them, you're modifying the timestamps on files you touch with specific utilities, and you are clearing specific event log IDs from the Windows event log or syslog on Linux. You make it look like you were never there. By the time they even realize something is gone, we're already ghosts.
So, we've covered the entire operational lifecycle, from start to finish. Let's bring it all together now. If you walk away from this with only one thing, it needs to be this philosophical shift. The work, it's not about finding a bug. It is, and it always will be, about achieving the objective. The bug is just a temporary tool, a means to an end, used to achieve a strategic goal.
This is the new mindset. You have to shift your focus from little client-side bugs to big, systemic server-side flaws. You need to stop thinking about just finding vulnerabilities and start thinking about how to chain them together to achieve a specific objective. You need to move beyond just using tools and graduate to deeply understanding the contract between the client and the server. You must learn to move silently instead of making noise, and you have to burn this into your brain. The mobile application is never the target. It is simply the key that unlocks the kingdom.
We've given you the framework. You have the blueprint from static analysis. You've observed the reality with dynamic analysis. You understand the principles of stealth, of lateral movement, and of exfiltration. The tools and the techniques, those are just details. The real question is what you do with this mindset. What objective will you achieve? And for God's sake, don't get caught.